12.7. So how do we go about doing these problems? It asks you to describe the three-dimensional object defined by each equation in spherical coordinates. So all of these are spherical. The question may be to recognize something in cylindrical. Now, let's start with A. What is rho? Rho is the distance from origin. Distance of x, y, z from origin. So now what I say, if I want to convert that equation A to the, what's the other one? Cartesian, I'm going to replace rho by that. And r is a constant. I can even write it as power 2. Now you know this is a sphere. And it is centered, origin, radius, right? Now let's do one more. Says b equal to 0, right? B equal to 0. Let me think about this. X, Y, Z. P is this angle made between Z and the position vector, right? Now, when is this angle 0? As I did right here, right? So any point over here, over here, over here, over here, that phi is equal to 0. And so the positive side of z-axis. And so sometimes it's easier to just know your geometry to recognize this equations, basically, rather than, could I have done this using the conversion formula? Yes, definitely. But I didn't have to. So that's the point. Sometimes it's easier to just recognize it that way. I'm going to do one more. C says phi equal to pi half. Okay. So that's the position vector P. This is not pi half. I have to go down, go down, go down, and stand on the XY plane. So when I'm on the XY plane, again, you can use the equations for the conversion and simplify and get here. But this one is easier to see just from fees, and I'm trying to prepare you. What is going to happen is that you're going to do a lot of integrals in 3-dimension. And so when you're doing the integrals in 3-dimension, recognition, a quick recognition is important. And so that, and then so phi equal to pi half is the XY plane. And so what is the phi equal to pi? You know it's going to be the negative side of z-axis. And for all the other phis, basically, you can simplify and figure out for phi not 0, not pi, not pi half, sorry, for C. B equal to C is a cone. It's just basically, this is the z-axis, and you're going to go keep the phi the same, and the purple is the position vector. So if you go about the z-axis with C angle, you make a cone. It's a map of a cone. Map of a cone. Questions? Are you guys with me still? Move on to different limits, differentiation, and so on and so forth. Okay, let's go. So what is chapter 14.1 to 14.5?